Hello, welcome back to the channel. Again, today I'll be talking about redox titration. Now, of course, all of us know redox. It includes oxidation reduction occurring in a cell reaction. Because, for example, in such a reaction, oxidation, this one loses electron, and the chloride will gain an electron, and hence we form this product. Now, indicators which are used in redox titration reaction, we can either use a voltmeter or potentiometry, or there are some dyes which will also change color due to redox, gaining an electron or losing an electron. Reduction potential, of course, I remember all of us know this. Standard, this is our test. All of us can remember this salt bridge. This is a measure or tendency of a chemical species to require electrons from or lose electrons. This is redox using potentiometry. We use reduction potential. A substance with a high reduction potential will oxidize one with a lower reduction potential, as shown in this equation. So, for example, let us first calculate reduction potential. Calculate the reduction potential of cerium. This is because this is redox. Using this electrode. This is the E which was measured. Now, this is its E. Now, when we're using standard Hydrogen potential, of course, we know that its E, the electromotive force, is 0. Because it's simple, just subtract, you get that 0. However, when we're using another electrode which has some reduction potential, which is lower, this is not minus, but the minus indicates the reduction potential of the silver and silver chloride electrode, which is 0.22 volts. When you subtract them, you get this. So this will be the measure on the voltmeter to expect it to get. So again, however, you can get scenarios where this one, the reduction potential of the cathode, is lower than the one on the anode. Now, of course, this reduction cannot happen because the other one has a lower reduction potential than the other. Another equation which we can come about is this. Complete the reaction and calculate the E cell. This one plus this one. Of course, there's that table which is in textbook which shows the reduction potentials of different compounds. The one for chlorine is this one. So it has a higher potential than bromine, of course, to oxidize it. That's why we can subtract it, and then we get the voltmeter will measure this, and then of course you have to complete the equation. As I've said, this is not always, it doesn't always happen. However, in all this reduction, we are talking about the concentration. So with the next equation, this equation, it talks about the concentration. What happens to the oxidized form, the reduced form. So with the next equation, we use this equation to determine the concentration in case we don't have it, or we determine E cell, it also basing on the concentration. I'm sure you know this equation. N, of course, refers to the number of electrons which are transferred. For example, in the above, we had 1 electron. Even this one, we can have 1 electron. I'm sure you can calculate this one using this equation. As I have already indicated to you, this one is oxidized, this one is reduced. Okay, so you just need to substitute in the above. You have the E0, then you get the answer. You can come up with that one. And there are also graphs which I have missed out. I'm sure you can draw them. Now, I will also have indicators which can be used, which can indicate signal change, or equivalence point. You can use potassium permanganate and all other indicators. So where can we apply redox titration? You can apply it in acyl ferrous salts, hydrogen peroxide, benzoyl peroxide. That's the pharmaceutical bit of it. So this has been a simple presentation. You can refer for more information. Thank you for listening to me and watching the presentation. These are the other ones that we have. I always remain Wilson. Subscribe to my channel, Empower Training Solutions. Contact us, we shall always get back to you. Thank you.